Similarly, we are having this another concept of this lithium bromide absorption system. So in this lithium bromide absorption system, in this system water is used as refrigerant, so it is uses for air conditioning only. In this LIBR is used as a absorbent, and the main components are generator, heat exchanger, absorber, solution pump, evaporator pump, condenser and evaporator. Boys, I already took this topic in the class and already explained this system for more than 2 lectures, so I'm expecting you already know this system very well. And here we are taking just revision only, so if you have any doubt then you can message me personally or you can call me personally. So this is just overlook purpose. Generator and condenser are located in high pressure vessel, and evaporator and absorber are located in low pressure vessel. Weak LIBR solution from absorber is circulated by solution pump to generator through the heat exchanger. Weak LIBR solution is heated by steam, and or hot liquid is heated coil due to converted into water vapor, leaving behind the strong solution and LIBR in the generators. Working is quite similar to the previous system, but only just refrigerant and absorber are changes here. The vapor refrigerant in condenser is condensed. The condensed water vapor at high pressure goes to the pressure reducing valve, where its pressure get reduced, and it goes to the evaporator due to the pressure drop in temperature and also drop in evaporator. This cool water is sprayed by evaporator pump on chilled water tubes which contain hot water from air conditioned space. During this, hot water is chilled in tube and get converted into the chilled water, therefore provides the required refrigeration load for air conditioning pressure, and sprayed cool water in converter into the water vapor. This water vapor is absorbed by strong LIBR solution, sprayed in the absorbent and convert it into the weak LIBR solution. Here you can see the schematic of this lithium bromide absorption refrigeration system. So here are the two chambers. It is low pressure chamber, it is high pressure chamber. In high pressure system, generator and condenser are placed, and in low pressure system, absorber along with the evaporator are placed. And I already explained the working of these in this theoretical manner before this. Now it's time to show you the actual working of this lithium bromide absorption refrigeration system on the YouTube.
Welcome to my YouTube channel. In this video, I teach you lithium bromide vapor absorption refrigeration systems. Which is the absorber, what is the refrigerants, its chemical. So, lithium bromide in the lithium bromide system, this lithium bromide is used as an absorber. So, its name suggests that the lithium bromide vapor absorption refrigeration system. So, lithium bromide is used as a absorber and water is used as a refrigerant.
I already tell you the same thing in our explanation.
Corrosive in this nature. So when this lithium bromide is used, we need to add some inhalators in that, and this lithium bromide is mixed with the lithium bromides to make the lithium bromides anti-corrosives. Okay, so how to draw this diagram? So this is a simple system. Okay, that is the aqua ammonia system that you knowing already. And if you don't know, then link is provided on the top right screen of your mobiles or the laptop. From that I symbol you can watch this video. Now in that case, these are the different systems, that is absorbers, evaporators, generators and condensers. But the schematic diagram for the lithium bromide system is different. So how that are making the cell? So in this lithium bromide system, the two cylindrical cell is made. One is the low pressure cell. So you know this evaporator and absorber have a low pressure inside that. So it is mixed in the one cell. Okay, so evaporator and absorber is put in this one cell, and the high pressure component, that is the generators and the condensers, are putting onto the another cell. So we have the two cell, that is a low pressure cell and a high pressure cell. In the low pressure cell, evaporator is there and absorbers. In the high pressure, generators and condensers. So I am moving to these another diagrams. Now in this component, this is our higher side, that is a higher pressure cell. In that is generators and condensers. And this lower pressure cell, evaporators and absorbers. So water is refrigerant, lithium bromide is absorbers. Now another component is this refrigerating pump, this is the solution pump, this is the heat exchangers. Okay, so these are the mainly components. Which are component? Absorbers, evaporator, generator, condensers, refrigerating pump and solution pump, and one heat exchangers. And another tube connections. Now I explain you how to draw these tube connections. So it is the most confusing things for the students to how to draw this tube connection, because there is a number of the tubes. So this first is the evaporator tube. Okay, now this tube is contain the brine solutions. Okay, in this tube some brine solution is in, that is cooled in evaporators, and it is out, and then it is.
Hello guys, welcome to my channel. In this video I am going to discuss the
I hope you understand this. I hope you understand this concept, and if still you have the queries, you can call me personally on my number and you can message me. Now it's time to check another concept. So this is the Carnot refrigeration system. This is the basic refrigeration system which we are using our this is the basic one. It is having efficiency 100%. So what is Carnot? It is having two isothermal process and two isentropic process, which is imaginary one. It is not occurs in practical life. Then we are going to see this TS and PV diagram of this vapor compression system. So this is the TS diagram and this is the PH diagram. You can see the explanation of this process. I already written here. Process 1 to 2 is the isentropic compression. Processor 2 to 3 is isothermal heat removal or condensation process. Then process 3 to 4 is isenthalpic expansion process. You can see this isenthalpic expansion process. During the isenthalpic process, the H remains constant. That's why this 3 to 4 it is straight line here, and 4 to 1 it is the isothermal heat absorption or evaporation. Now advantages of VCR over Carnot cycle. VCR is smaller in size and having low running cost as compared to the Carnot cycle, and a Carnot cycle cannot be possible in practical. It is imaginary one. Now again, the COP of vapor compression cycle is high as compared to the Carnot, and control over vapor compression refrigeration system is easy as compared to the Carnot cycle. The disadvantages of vapor compression refrigeration system is that its cost is high and is required greater safety. Now let's going to see the next concept. Then this is the thermal analysis of our vapor compression refrigeration system. thermal analysis means what we are going to there are the 4 different types. You can say that what all the different changes you can made. So first one is the when vapor is dry and saturated at the end of compression. Here you can see that how vapor, I already explained this in the class, that this is critical point, and in that region it is subcooled region, it is superheated region, and this region is the wet region. Then how this evaporator is entered in compressor when it is superheated. Here wet refrigerant is entering the compressor and leaving the compressor in the form of saturated refrigerant. Here what happening, here the refrigerant entering the compressor is wet, always, as well as the refrigerant leaving the compressor is also wet one. Here what happening, the refrigerant entering in the compressor is superheated and refrigerant leaving the evaporator is also superheated. Here what happen, here we are producing the subcooling. How we are producing subcooling, what are its effects, I already mentioned here, you can read it. Okay, and we already spent much more time on this concept in the class itself. So here are again the type of this analysis, that effect of reduction in suction pressure. Suction pressure is here in the bottom line. So here is in reduction in suction pressure and increase in discharge pressure. So you can see this, we are increasing the discharge pressure from 0.2 to 2 dash. So this is the increase in discharge pressure. And effects is already written here, that work done on compressor increases, the refrigerating effect decreases, COP of the system also decreases, and effect of reducing suction pressure is that compressor work increases, refrigerating effect decreases, and coefficient of performance also decreases here.